You think time is simple. You imagine it as a straight line stretching from the past through you into the future. You believe there is a universal now, a shared present, a single invisible clock ticking behind the entire universe. It feels obvious. When something happens, it happens at a time, the same time for everyone. That assumption feels harmless. It isn't, because the moment you ask what now actually means, far away, moving fast, deep in gravity, your certainty begins to crack.
You assume time flows. You assume it flows the same everywhere. You assume the universe agrees with your watch. It does not. Physics does not recognize your shared present. It does not guarantee your seconds are universal, and it certainly does not promise that time behaves the way your intuition insists it must. The problem is not that time is complicated. The problem is that your picture of it is wrong. Not slightly wrong, fundamentally wrong.
On or the myth of the universal clock. You believe there is a single clock behind the universe, not a literal clock with gears. Something deeper, a shared ticking, a cosmic rhythm that every event obeys. You assume that when something happens now, that word means the same thing everywhere. If a star explodes in a distant galaxy at this moment, you imagine that explosion sharing your present, different location, same time. That feels unavoidable. It is also wrong.
And D, imagine two lightning strikes hitting opposite ends of a moving train. You stand on the platform exactly midway between the strikes. The light from both flashes reaches you at the same time. You conclude they happen simultaneously. Now imagine someone sitting inside the train, also exactly midway between the ends of the carriage, but the train is moving forward. To that observer,
the front of the train is moving toward the light from the forward strike and away from the light from the rear strike. The light from the front reaches them first. They conclude the front lightning strike happened earlier. Both observers are correct. There is no hidden referee who steps in and declares which one really happened first. Physics does not choose a winner. Simultaneity depends on motion. This is not a trick of perception. It is not about delayed signals or faulty instruments. Even after correcting for all signal travel times, the disagreement remains. It is built into the structure of reality. You thought at the same time was an objective statement. It is not. The phrase only has meaning relative to a particular state of motion. This alone should unsettle you, because your entire mental model of time relies on a shared present. You imagine the universe sliced into neat layers of now, stacked one after another like pages in a book.
but those slices depend on how you are moving. Change your velocity, and your slice through the universe tilts. Events you consider simultaneous are not simultaneous for someone moving differently. Events you think are still in the future may already belong to someone else's past. There is no universal page turning, no master clock ticking behind everything. In classical physics, time was absolute.
Newton assumed it flows equably without relation to anything external. That assumption felt natural because it matched human experience. Our daily speeds are slow, our distances are small, the differences are too tiny to notice. But nature is not obligated to preserve what feels natural. Einstein showed that if the speed of light is the same for everyone, then time cannot be. You cannot keep both. One must give, and what gives is your intuition.
There is no single cosmic now spreading across the universe. There is no invisible drumbeat synchronizing distant galaxies with your wristwatch. There are only relationships between events. Time is not something happening to the universe. It is something defined within it. And once you remove the universal clock, the comfort of a shared present dissolves. When time refuses to agree, you might accept that simultaneity is relative, but you probably still believe something deeper remains untouched. You may think, fine, observers can disagree about when things happen, but surely time itself still passes at the same rate. Surely a second is a second everywhere. It isn't. Consider a simple device. A light clock, two mirrors face each other, a pulse of light bounces between them, one bounce up and down marks one tick. It is simple, no gears, no springs, just light. Now imagine this clock is sitting still beside you. The light travels straight up and straight down, tick-tock. Now imagine the clock is placed on a spaceship moving past you at enormous speed. From the astronaut's perspective, the light still travels straight up and down between the mirrors. But from your perspective on Earth, the spaceship is moving sideways. So the light inside the clock does not move straight up and down. It traces a diagonal path, a longer path. The speed of light cannot change. That is the rule nature enforces. If the path is longer and the speed is fixed, the tick must take longer. The moving clock runs slow, not because it is damaged, not because it is malfunctioning, because time itself stretches. This is time dilation. It is not theoretical. We measure it. Atomic clocks flown on airplanes return slightly out of sync with those left on the ground. Particles created in the upper atmosphere live longer when moving near light speed than they should if time were universal. And motion changes the rate at which time passes, but motion is not the only thing. Gravity does it too. Place one clock on a mountain and another at sea level. The clock closer to Earth's mass, deeper in gravity's pull, ticks more slowly. Again, not metaphorically, literally. GPS satellites must correct for both their speed and their weaker gravitational field. Without those corrections, your maps would drift kilometers off course. You think gravity pulls on objects, it also pulls on time.
Near a black hole, this effect becomes extreme. To a distant observer, a clock falling toward the event horizon appears to slow down more and more. It never seems to cross the boundary. Its final moments stretch indefinitely. For the falling observer, nothing unusual happens at the horizon. Two perspectives, two time flows, both valid. This is the part that should disturb you. Time does not simply pass. It responds, it bends, it dilates, it refuses to remain consistent across the universe.
And there is no hidden true rate beneath these differences. There is only the rate measured along a particular path through space-time. Your wristwatch is not measuring universal time, it is measuring your time. And someone moving differently or sitting deeper in gravity is not living through the same duration you are. Seconds are not shared currency, they are local experiences. By now, the idea of time as a steady river should feel less stable because rivers do not change their speed depending on who watches them. Time does. Space-time, the collapse of separation. Up to this point, you may still be trying to protect something. You might think, fine, clocks disagree, fine, motion and gravity affect duration, but time is still separate from space. It is still the background in which space exists. That separation feels obvious. There is where something happens, and there is when it happens. Two different questions. But relativity does not treat them that way. Imagine again the moving train and the lightning strikes. The disagreement about simultaneity did not come from faulty clocks. It came from how space and time transform together when you change motion. If you try to keep space fixed and adjust only time, the equations break. If you try to keep time fixed and adjust only space, they also break. The only way the universe remains consistent is if space and time mix. Change your velocity in what counts as space and what counts as time, reshuffle. This is not poetic language, it is structural. Think of space-time as a single four-dimensional geometry, not three dimensions of space, plus a separate ticking parameter, but one unified fabric. When you move, you are not just moving through space, you are rotating your orientation in space-time. Different observers slice this four-dimensional structure differently. What you call now is simply one particular slice through the geometry. Someone moving differently slices it at a different angle. There is no privileged slicing. You keep trying to imagine time as a flowing substance laid over space, but in relativity, time behaves more like a direction within geometry. Distance in space depends on how you measure it. Duration in time does too, but there is something deeper that remains invariant. The space-time interval, not space alone, not time alone. Today's the combination. This is the shift Hawking inherited and worked within. The universe is not evolving inside time. The universe is a space-time structure. Planets do not move because time pushes them forward. They follow paths, geodesics, through curved space-time. Gravity is not a force pulling objects through time. It is the curvature of space-time itself. Mass tells space-time how to curve. Curved space-time tells matter how to move. Notice what has disappeared.
The idea of time as an independent stage. There is no empty temporal river flowing beneath events. There is only the geometry that contains both where and when as inseparable aspects of a single reality. You cannot ask what time is doing without also asking what space is doing. They are not partners. They are the same entity viewed from different angles. And once that separation collapses, the language of time passing starts to sound suspicious. Geometry does not pass.
Here it simply is. The block universe and the death of becoming. Even now, you may be holding on to one last refuge. You might accept that time is relative. You might accept that space and time form a single geometry, but you still feel that the present is special. You still feel that the past is fixed, the future is open, and the present is where reality truly happens. That feeling is powerful. It may also be an illusion. If space-time is a four-dimensional structure, then every event, past, and present, future, exists within that structure. Not sequentially, not emerging, simply existing as part of the geometry. Imagine a map of Earth. The map does not create cities as you scan across it. Paris does not come into existence when your finger reaches France. Tokyo does not wait in some unrealized state until you turn the page. All locations coexist within the map. Your movement across it is not the map unfolding. It is you tracing a path. The block universe is similar. And your space-time is the full structure. Every event you call past and every event you call future is part of that structure. Your life is a world line through it, a path. From within that path, you experience moments in sequence. Memory gives you a direction, anticipation gives you uncertainty. But from the outside, there is no privileged present moving forward. There is no spotlight sweeping across space-time, bringing events into existence one by one. The equations of relativity do not contain a flowing present. They describe a static geometric whole. This idea is deeply uncomfortable because it challenges becoming. You feel like the future does not yet exist. You feel like it is being created moment by moment, but physics does not require that story. In the space-time picture, tomorrow is as real as yesterday. It is just located differently along your world line. The sense of now is not a feature of the universe. It is a feature of conscious experience embedded in it. There is no global clock advancing the cosmos from one slice to the next. There is only the totality. This does not mean you can access the future. It does not mean determinism is fully understood. Quantum mechanics complicates that story. But within relativity, the structure itself does not evolve. It contains. And if reality is a block rather than a flow, then time is not something that moves. You move. Or along a dimension that does not need to pass in order to exist. The death of becoming is not dramatic. It is quiet. It is the realization that the universe may not be unfolding at all. It may simply be there. The arrow of time and the illusion of direction. You still feel time moving forward, even if space-time is a block, even if simultaneity is relative, even if clocks disagree. You remember yesterday. You do not remember tomorrow. Ice melts. It does not unmelt. Eggs break.
If they do not reassemble themselves, this direction feels fundamental. It feels written into reality. But the basic laws of physics do not care about direction. If you take the equations governing motion, electromagnetism, even much of quantum mechanics, and run them backward in time, they still work. The mathematics does not protest. At the microscopic level, processes are largely time symmetric. So where does the arrow come from? Not from time itself, from entropy. Entropy is not disorder in the casual sense. It is the number of microscopic arrangements consistent with a macroscopic state. There are vastly more ways for molecules to be spread out than neatly arranged. Vastly more ways for a glass to be shattered than intact. When systems evolve, they move from less probable configurations to more probable ones, not because they are pushed forward by time, but because statistics overwhelmingly favor those directions. The arrow of time is an arrow of increasing entropy. You experience the past as the set of lower entropy states that left records. You experience the future as the higher entropy states toward which systems are overwhelmingly likely to evolve. Memory itself depends on entropy increase. To store information, your brain must dissipate energy. Recording the past requires irreversible processes. You cannot remember the future for the same reason smoke does not gather itself back into a cigarette. Not because time forbids it, because entropy makes it fantastically unlikely. Here is the unsettling part. If the direction of time depends on entropy, then the arrow is not fundamental. It emerges from boundary conditions, from the fact that the universe began in an extraordinarily low entropy state. Why did it begin that way? Physics does not yet fully answer that question. But without that special beginning, there would be no thermodynamic arrow, no clear distinction between past and future, no memory gradient. Your sense of time flowing forward is built on statistical asymmetry, not on a cosmic engine pushing events from behind. Remove the entropy gradient and forward loses meaning. Time itself does not contain direction. Direction is something layered on top. You do not feel time moving, you feel entropy increasing. When time disappears from the equations. So far, time has survived in some form. It bent, it stretched, it lost its universal status. It merged with space. It lost its direction, but it was still there. Now we go deeper. General relativity describes gravity as geometry. Quantum mechanics describes matter and energy in probabilistic terms. Both theories work extraordinarily well in their own domains.
But when you try to combine them, when you ask what happens at the very beginning of the universe or inside a black hole, the mathematics becomes unstable. And something strange happens. In some formulations of quantum gravity, the fundamental equation that describes the universe does not contain time at all. No ticking parameter, no evolution variable, just a static equation describing the entire quantum state.
Sheena, this is sometimes called the problem of time. At the deepest level we can currently probe, the universe may not evolve in time. Instead, what we perceive as evolution could emerge from correlations within a timeless structure. Stephen Hawking explored this possibility through the idea of imaginary time. The term sounds mystical, it is not. In certain mathematical treatments, you can replace real time with an imaginary number, multiplying it by the square root of -1.
When you do this, the equations describing the early universe become smoother. The singularity at the beginning disappears. Instead of a sharp beginning in time, you get something more like a rounded surface, like the North Pole on Earth. There is no point north of the North Pole, not because something dramatic happens there, but because the concept loses meaning. Similarly, near the origin of the universe, the distinction between time and space may dissolve.
Time behaves like another spatial dimension, and if that is true, then asking what happened before the Big Bang may be like asking what is north of the North Pole. The question assumes a direction that may not exist. In these models, time is not fundamental, it is emergent. It appears when the universe becomes large and structured enough for classical space-time to make sense. But at the deepest quantum level, reality may simply be a static configuration of relationships, no flow.
No ticking, just structure. And what you experience as temporal evolution could be your consciousness tracing a particular pattern within that structure. If time can disappear from the most fundamental equations, then it is not the bedrock of reality. It is a feature that arises under certain conditions, like temperature, like pressure, real in experience, but not fundamental in essence. What remains when time is not what you thought? Now the structure stands exposed.
And no universal clock, no shared present, no independent time separate from space, no guaranteed flow, no fundamental direction, possibly no time at all at the deepest level. What remains? Not chaos, structure, relationships between events, correlations between states, geometry connecting what you call before and after. If space-time is a block, then existence is not something that unfolds. It is something that is. Your birth is not emerging from non-existence.
Your death is not falling into nothingness. They are locations in a four-dimensional structure. You experience passage because your consciousness is arranged along a path that encodes memory in one direction and anticipation in the other. The universe does not need to move for you to feel movement. The block does not need to update for you to feel change. What you call now is not a feature of the cosmos. It is the intersection of awareness with structure. This does not diminish reality. It makes it stranger because it suggests that becoming may not be fundamental, that the drama of unfolding events is not written into the equations, that the difference between past and future may be a perspective-dependent feature of beings embedded within the geometry. Hawking's work did not simply bend time, it stripped it of privilege, and what remains is not a river carrying you forward, it is a vast silent architecture.